Okay, this is a very typical problem in which there is a man, and the man is in a cabin. This is not a lift which is written a man in a lift, but this is actually a cabin because the lift cannot be 20 kg, right? Whatever. So this cabin is of 20 kg mass and the man is of 60 kg mass, and the man is pulling this rope. Okay, you can see this, rope, and the rope is attached to the cabin in one point. So there is only one tension force on the cabin, right? So eventually there is a acceleration downwards. So that is very important, right? So you have to first think that eventually what is the motion, right? It is going downward with an acceleration of g by 4. Okay, so I mean, now I'll take two systems. One is the man, another is this cabin without the man, right? So let me call this a system 1, and let me call the cabin system a system 2. So let me draw the free body diagram of S1. Okay, now this is our man. So as you know that we can draw a single point because that is the center of mass of the man as depicted by Newton's laws of motion, right? Now see how many forces are working on this man. Obviously downward weight. Now what is the weight? 60 kg into 10 mg. That means straightforward I can write 600 Newton. I am not writing the unit, I am just writing 600 Newton because the problem is in SI unit. Now the man is standing on the cabin, right? So there must be upward force which is a contact force, right? Always. And the man is pulling this rope downwards. So by Newton's third law, the rope will pull the man upward, isn't it? Because the man is pulling the rope. All right. So this is the free body diagram. Okay. So the tension will be upward. There is another N force, and there are total 600. So what is the equation? Eventually the man is going down with G by 4. So what we'll write? 600 minus N, oops, just a moment please. Okay, here you go. 600 minus N minus T is equal to mg by 4, right? The ma. So here A is g by 4. So what we can write? 60 into g is how much? Into 10 by 4. So instead of that we can write 600 minus N minus T is equal to 600 divided by 4, which is nothing but 125. This is our first equation. Okay. All right. Now let's come to the second system. Now there is a cabin, right? Now what are the forces on the cabin? Okay, this is the cabin. The cabin is going downward. Now what are the forces? Look at this. There is a rope over here. So this rope is pulling it up. So tension is T. Why it's T? Because it's the same light rope. So this T and this T should match. Okay, same force T. What is the what else is there? Look at this. This man is standing on this cabin. So the cabin is pulling giving a reaction force of N. So by third law, this man will give a force N back to this cabin. All right, and of course the weight of the cabin. Now what is the weight of the cabin? I think 200. Now again the cabin is going downward, right? So what we can write, T minus 200 minus n is equal to MA. MA means 20 into 10 by 4, because the acceleration is g by 4, instead of g I am writing 10. So this is 200 by 4. So what I can do, I can directly write it 50, right? Isn't it? Let me write just a moment. I can write it directly as 50. Here you go. So we got two equations, two unknowns. What are the unknowns? T and n, right? Now we have to find out what? We have to find out T. We have to find out T. Let's see how we can find out that, right? Because it's the force exerted by the boy on string, which is nothing but T. So what we can do, we can subtract this, okay? We can subtract this. So then n will cancel out. So this is 800, then minus T, this is minus T minus 2T, equal to how much? 125 minus 50, that is 75. Okay, so 2T is coming out to be 800 minus 75, that is 725. So T is how much? T is 725 divided by 2 Newton. And that is the answer. You can rewrite it as 362.5. That's it.